All right, we're talking about section 1.2 now. You can see that the learning objectives are that you should know how to find zeros of a function, you should know how to graph linear and piecewise functions, and you should be able to identify functions that are even or odd functions, and of course what that means. Okay, so the first thing when we talk about functions that you need to know are these terms that you've heard many times, and we've already talked about it in class, and those are domain and range. So the domain of a function refers to the set of all possible input values, usually that's x, and the range refers to the set of all possible output values, and usually that's y. I'd like you to go ahead and look at page 85, example 1. And there's just a basic example there asking you to look at a graph and then just by looking at the graph to identify the domain and the range. And basically I just want you to be able to do this, to be able to look at a graph and identify what the domain and range of that function are. So you can see that the domain scans all the possible x values, which are the horizontal values of the function. So the furthest left that the function goes is -1, and the furthest right that the function goes is 2. But you'll notice that the point that exists at 5, 2, well, it actually doesn't exist. It's an open point, so it's not part of the graph. And that's why your domain here goes from -1 on the left side, oops, and that should be a bracket, because it does include -1, and then it goes all the way to +5. Right, those are the x values from left to right. Whereas the range, looking from bottom to top, the lowest point is -3, has a value of -3, and the highest point has a value of +3. So, and both of those points are included in the function, so that's why you have the brackets for the range. The next example talks about the vertical line test, example 2, and so it's pretty basic. Let me just talk about it here. If you think about this graph, the reason why this graph does not represent a function is because if you were to scan a vertical line through this graph, anywhere you choose really, you'll see that for whatever x value this is, let's say it's x equals some value c, you can see that there are two different y values. And so functions, remember, for every one input, you can only have one output. And so this one value x equals c has two different outputs, and that's why it's not a function. So that's why the vertical line test works. All right, next we will talk about zeros of a function. So when we talk about zeros, zeros are x values for which the function is equal to 0. Okay, so finding zeros is actually fairly simple. If this is your function, then to find the zeros, you would set the function equal to 0 and figure out what x value or values makes that function equal 0. In this case, you can factor this. What do we got here? -2 and +5. So you can see that your x values are -5/3 for this one and +2. So these are your zeros for example 1a. Example 1b and 1c, you can just read over those. They're pretty basic. And of course, you can check graphically whether your zeros are correct because the zeros correspond to x-intercepts when you are to graph this function. The next topic is determining intervals on which a function increases or decreases. This is not really that difficult. Let's see. I think looking at example 4b is pretty instructive in this. So they kind of have this graph. They label this point. This is -1, 2, and this point is 1, -2. Okay, so you can see, and I'll use a highlighter here, Hopefully you can see it. You can see that the first part of the graph from here until it gets to that point is increasing. And then the second part of the graph, starting from that top point, is going down, so it's decreasing. But then the third part is increasing again. So there are three different intervals that you have to describe here. Okay, so the first interval on the left starts at negative infinity and goes all the way up to x equals -1. The third interval starts at x equals 1 and goes to infinity. The middle interval starts at x equals -1 and goes to x equals +1. So the blue one is the interval where the function is decreasing. So f is decreasing on that, whereas the red ones are where f is increasing. Now, when you define intervals on which a function is increasing or decreasing, you are referring to the x values, right? Not the y values. So intervals refer to x values. That's why, in this particular case, the y values, oops, sorry about that, I meant that to be a highlighter. The y values, 2 and -2, are irrelevant to this situation when you're just talking about identifying intervals. Now I'm going to go ahead and use this example to talk about relative minimum and maximum values. So when they talk about relative minimums or maximums, they are talking about the y values, okay? So in the diagram we have here, we can say that f, I wanted that to be a regular pencil, sorry, that we could say that f has a relative maximum, so it's like the top of a hill, relative maximum value of 2, right? Because the y value is 2. Now, usually when people identify maximums and minimums, they refer to the location of it. So you could say that it has a relative maximum, f has a relative maximum at the point -1, 2. And it has a relative minimum, which is like the bottom part of a valley, at the point 1, -2. But when we talk about the maximum values or minimum values, we're talking about the y values, right? The y is what gives us the value of the function. The next couple of examples in your book just talk about graphing linear functions and writing linear functions. I'm just going to leave those to you to read over and make sure you know how to graph lines. If you don't, this might not be the class for you. Okay, the thing I do want to talk about, though, is how to graph a piecewise function. So let's look at example 8. They give us this function, f of x, defined by two different pieces. So it is equal to 2x plus 3 if x is less than or equal to 1, but it's equal to -x plus 4 if x is greater than 1. Okay, so here's how I graph it. First of all, you should recognize right away that the first one is a linear piece, and the second one is also a linear piece. So because they're lines, you only need 2 points to graph them. So what I like to do then is, for this first one, I'm just going to make a little XY chart, and I need to pick x values that are less than or equal to 1. So I'll pick 1, and I'll pick 0. So when x is 1, y will equal 2 times 1 plus 3, so that's 5. When x is 0, y will equal 2 times 0 plus 3, which is 3. Okay, that gives me 2 points to graph. Now for the blue one, I'll make another XY chart, and I'm supposed to pick x values that are greater than 1. Now here's a little trick. I'm going to pick 1, and I'll explain why in just a second, and then I'll go ahead and pick 2. So when x is 1, y is -1 plus 4, which is 3. When x is 2, y is -2 plus 4, which is 2. Okay, but what I have to remember is that this point is going to be an open point, because the interval right here does not include x equals 1, but it just goes really up to where x is equal to 1. Okay, so when you graph this, let's see, 1, 2, 3, 4, 5. Okay, so the red one is going to hit here and then go to here. And because it's less than or equal to 1, it's just this, and it continues to the left. Okay, now for the blue one, at 1, 3, I'm going to put an open circle, and then I need another point at 2, 2. So 2, 2 is going to be a regular point, and this is for all x values greater than 1. So greater than 1 is to the right. And so that's how you graph a piecewise function. Now, going back to why did I choose x equals 1 when clearly it says that x has to be greater than 1? Well, the reason is because I want to know as the blue line is approaching the middle, right? So the middle is x equals 1 is where this graph transitions. So as the blue line is approaching 1 from the right, where does it hit that boundary line? I need to know where it hits the boundary line. Okay, even though it doesn't include the actual point on the boundary line, I want to graph that point and just leave it as an open circle. Okay, finally, our last topic is even and odd functions. So they give a definition. Let me grab a photo of that. So here are the definitions for what even functions are and what odd functions are. So basically an even function is a function that has symmetry with respect to the y-axis, right? And the way that you test for that is that if you plug in f of x or you plug in f of negative x, they equal the same y value, right? So that means that there's symmetrical points on each side of the y-axis. Whereas origin symmetry means that when you replace x with negative x, you get the exact opposite y value. So spend a few moments to really make sure you understand why that test works and why this test works to determine whether a function is even or odd. Okay, so here are two examples, and I will show you how to execute the test. So the way the test works is, first thing we do is we replace x with negative x. Okay, so if we do that, replacing x with negative x, we get that. Now let's simplify this. This negative x to the third power is the same thing as negative 1 times x cubed, and minus negative x, so that's going to be plus x. But what you'll notice here is that we could factor out a negative, and now we get x cubed minus x. And of course, x cubed minus x is the original function. So this is g of x. And so we have just proven that when you replace x with negative x, you get the exact opposite of the function. So this proves that g of x is an odd function, which means it has origin symmetry. For the other one, again, you replace x with negative x. So h of negative x is equal to that squared plus 1. Negative x to the second power is, of course, the same thing as positive 1x squared. And so x squared plus 1 is the original function. So therefore, that's just h of x. So h of negative x is equal to h of x. So this proves that h is an even function. Now, of course, most functions are neither even nor odd, but if you're able to identify when you have an even function or an odd function, it makes it easier to graph. Sometimes it helps to analyze situations. So it is important for you to be able to identify even and odd functions. All right, that concludes our time, and I hope you enjoy the rest of your weekend. See you on Tuesday.